This is a video from eSkillZone. For more videos, notes, and certificates, please visit www.eskillzone.com. Hello. In the previous video, we have discussed the classification of the computers. We know that computers have many types, but the most popular type, used by the customers of the computers, is the desktop computers. In this video, we will learn the internal structure of the desktop computer. There are further two types of desktop computer. Here, we discuss about the tower PC. Basic structure of computer. All types of computers follow a same basic, logical structure and perform the following 5 basic operations for converting raw input data into information useful to their users. Following diagram shows the basic structure of computer. Input unit. This unit contains devices with the help of which we enter data into computer. This unit makes link between user and computer. The input devices translate the information into the form understandable by computer. CPU, Central Processing Unit. CPU is considered as the brain of the computer. CPU performs all types of data processing operations. It stores data, intermediate results, and instructions called the program. It controls the operation of all parts of computer. CPU itself has following 3 components: ALU, arithmetic logic unit, memory unit, control unit, output unit. Output unit consists of devices with the help of which we get the information from computer. This unit is a link between computer and users. Output devices translate the computer's output into the form understandable by users. In computing, an arithmetic logic unit, ALU, is a combinational digital circuit that performs arithmetic and bitwise operations on integer binary numbers. This is in contrast to a floating point unit, FPU, which operates on floating point numbers. It is a fundamental building block of many types of computing circuits, including the Central Processing Unit, CPU, of computers. FPUs and Graphics Processing Units, GPUs. The inputs to an ALU are the data to be operated on, called operands, and a code indicating the operation to be performed. The ALU's output is the result of the performed operation. In many designs, the ALU also has status inputs or outputs, or both, which convey information about a previous operation or the current operation, respectively. Between the ALU and external status registers. An ALU has a variety of input and output nets, which are the electrical conductors used to convey digital signals between the ALU and external circuitry. When an ALU is operating, external circuits apply signals to the ALU inputs, and, in response, the ALU produces and conveys signals to external circuitry via its outputs. Let's talk about some of history of the ALU. Mathematician John von Neumann proposed the ALU concept in 1945. In a report on the foundations for a new computer called the EDVAC. The cost, size, and power consumption of electronic circuitry was relatively high throughout the infancy of the information age. Consequently, all serial computers, and many early computers, such as the PDP-8, had a simple ALU that operated on one data bit at a time, although they often presented a wider word size to programmers. One of the earliest computers to have multiple discrete single-bit ALU circuits was the 1948 Whirlwind 1, which employed 16 such math units to enable it to operate on 16-bit words. In 1967, Fairchild introduced the first ALU implemented as an integrated circuit, the Fairchild 3800, consisting of an 8-bit ALU with accumulator. Other integrated circuit ALUs soon emerged, including 4-bit ALUs such as the AM2901 and 74181. These devices were typically bit slice capable, meaning they had carry look-ahead signals that facilitated the use of multiple interconnected ALU chips to create an ALU with a wider word size. These devices quickly became popular and were widely used in bit-slice mini-computers. Microprocessors began to appear in the early 1970s. Even though transistors had become smaller, there was often insufficient die space for a full word-width ALU and, as a result, some early microprocessors employed a narrow ALU that required multiple cycles per machine language instruction. Examples of this includes the popular Zilog Z80, which performed 8-bit additions with a 4-bit ALU. Over time, transistor geometries shrank further, following Moore's law, and it became feasible to build wider ALUs on microprocessors. Modern integrated circuit (IC) transistors are orders of magnitude smaller than those of the early microprocessors, making it possible to fit highly complex ALUs on ICs. Today, many modern ALUs have wide word widths and architectural enhancements, such as barrel shifters and binary multipliers, that allow them to perform in a single clock cycle. Operations that would have required multiple operations on earlier ALUs. The structure of the computer's system unit should be considered in detail because it includes many important components that directly or indirectly affect the system's overall performance. These components include motherboard, CPU, RAM, hard disk or solid-state drive, video card, sound card, PCI devices. The structure of the computer processor. It is believed that the CPU is the most complex digital device in the computer. It is made in the form of a silicon wafer in a casing with a number of leads that are connected to a special socket on the motherboard. On silicon, a substance is produced that reproduces a complex but very small electrical circuit. The structure of the motherboard. Of course, you need to consider building a computer motherboard. The motherboard is a complex device with a multi-layered circuit. It contains the main sockets for connecting all other computer devices, sets of logic so that all components work interconnected, controllers of the main interfaces, sound card, network card, input-output devices. RAM. RAM stands for the Random Access Memory. Describing the internal structure of the computer, this element cannot be bypassed. The RAM stores temporary data and CPU commands, for which there is not enough space in the cache. The most important characteristics of memory are frequency, volume, generation, and timings. Video card. The structure of a personal computer in the modern world necessarily assumes the availability of a video card. In simple terms, this device prepares and generates graphic information, which is subsequently displayed on the screen. The video adapter can be integrated into the computer's motherboard or connected to the PCIe connector. HDD. A hard disk drive is used to store data. It is on it that the OS, games, programs are installed. It is it that stores music, videos, photos. The structure of the computer is such that any device can be replaced with a similar one without problems, but after changing the HDD, all user data is lost. Therefore, to devices of this type, the highest reliability requirements are presented. Power supply. When describing the anatomy of the computer or the structure of the computer, often information about this component is deleted. And in vain. The power supply depends on the stability of the entire system. Its main characteristic is power. The modern market offers a choice of devices from 300 watts to 1,600 watts. As informatics says, the structure of the computer is absolutely independent of the chosen power supply. They are universal and suitable for any configuration. However, more powerful power supplies have a larger size and an increased number of the same type of connectors. In most cases, the number of connectors is redundant, even on power supplies with the lowest power. It is better not to use cheap PBs manufactured by manufacturers without a name. Low voltage, 3 to 12 volts, is applied to the PC devices, and even a slight fluctuation of this indicator can disable any piece of hardware. In addition, in practice, such power supplies produce a quarter of the power compared to the data in the passport. We hope you like this video. Our next video will be on the input devices. See you next time. This is a video from eSkillZone. For more videos, notes, and certificates, please visit www.eskillzone.com.